All right. Did it switch on you?
It did.
Oh, then that's interesting. That must have been me. We got John Dryden today, so I'm just gonna let him speak away. Thanks, John.
Yeah, try. Get this to behave normally.
Is it working?
Yeah, it wouldn't show the run, but I think we're there now. Okay. Hi, everybody. I'm John Dryden. I teach here as well. I don't know if I've had you in class yet since you're in your first year, most of you probably. I may have had you online last term, but or this term you may be in one of my graphics classes, but you're well familiar with Troy teaching kind of the heart of the engineering technology program, and I'm kind of a counterpart teaching the main part of the engineering transfer program. So I'm here today to kind of give you a bit of an overview about that program. And I'm a civil engineer by licensure, so I'll talk a little bit about civil engineering. We'll talk about my education and work experience. Just I think overall the kind of idea of these lectures is to introduce you to different fields of engineering and different ways of getting there. So to help me know where you guys are coming from, can you guys just ask a couple questions of you guys first? How many of you are engineering tech students? I think that's probably a good chunk. Okay. How about engineering transfer is your hope or goal? Okay. So a mix. Great. Do you guys have any idea of majors yet? I know if you're taking 101, that's kind of no problem if you don't, but anybody think you want to do something mechanical engineering related? Okay, that's usually a pretty common one. How about electrical? Okay, that's great. And civil? Okay, some hands haven't raised yet. Anybody brave enough to shout out there what you're hoping or environment? Okay, great. So that's awesome. Yeah. Aeronautical. Okay, cool. So just perspective there, I think of those as totally they're, degrees. And at this level, I kind of think of each one of those as being under one of the big civil or mechanical. Like aeronautical, you're probably going to do mechanical and then specialize in aeronautical. And environmental now is getting to be its own thing, kind of a mix of chemistry and civil engineering, but it's probably under that civil umbrella. Any other majors out there that you think you're interested in? No electrical. Well, that's nice. Well, you're welcome to do electrical, but I just feel obligated to tell people if they're looking into electrical that Mount Hood's not the best fit there. We're a small program and we don't have a lot of the electrical precursor courses. So it's nice I don't have to give any of you bad news today. Okay, so I'll go ahead and just get started a little bit about me. I started out, I've lived in the Northwest my whole life, got interested in engineering probably about like third or fourth grade, liked taking things apart and putting them back together, not always the same way kind of thing. In high school, I did a mix of high school and college. I don't know if any of you are like, I can't remember what we call it here, college now or middle college or like, but anyways, I was taking classes for engineering when I was in high school and loved that. That was a great experience. As soon as I graduated from community college, so here's one thing applicable to you guys. I got my first degree in engineering technology. So I got an AAS in industrial electronics technology, kind of automation, robotics, control systems, that kind of thing. So we'll talk a little bit more about that difference. And Troy, have you already talked significantly about that? Like, should I not waste their time about? Okay. So we'll talk about that process of tech, and then I'm now a professional engineer, so that's kind of a different track that I switched to later. But as soon as I got that 2-year degree, I went out and got a good paying job. Actually, I started this job while I was still getting my 2-year degree and loved that. Traveled a lot, installing big control systems, places like big CNC machines that created molds for boat parts or airplane wings, like machining centers that would be like the width of this classroom and twice as high and 3 times as long, just these giant machines. It was really cool, and did projects for Intel, things like that. Then I went back and taught at Clark for a little while, just ran an electronics lab kind of thing, and that was my first exposure to kind of working with students, and I enjoyed that. But to be honest, working in education isn't as financially lucrative as outside of that. So I ended up going back to industry, Worked for a company called, actually a couple of companies throughout this thing I've summarized here. All around the idea of industrial automation, again, specifically programmable logic controllers, which are like these industrial computers that control machines. And so I worked in one job where I integrated those for companies, another one where I sold those to companies, another one where I was tech support for those. So that was kind of my first foray into doing a lot of programming and stuff like that. Went to another motion control. Here is where I actually built these control systems. I would design them. So this was the first job where I was probably moving more into the engineering role instead of engineering tech role, where I was actually creating new parts, not assembling somebody else's design. Yeah, so, and then kind of made a big veer in my career at this point. So right now I'm maybe, it would be like 6 years out of my first 2-year degree kind of thing. And I had been building a house for my wife and I in nights and weekends and kind of things. And I really found I really loved doing that, working outside and whatnot. So I quit my job at US Digital, and a friend asked me if I would build a house for them. So I said, sure, I'll do that while I look for another engineering job. But that ended up snowballing into 8 years of running a construction company. And that was fun. I love building things. So then when the housing market started slowing down, I decided if I was ever going to go back and finish and get a bachelor's degree, a 4-year degree in engineering, that would be a good time to do that because work was slowing down. So while I was kind of finishing the last few development projects I had, I went back to school at Portland State and got a bachelor's degree in civil engineering. While I was there, I found out through a required like junior level course, you had to take this one geology course, and I loved it. Yeah, question?
So, that was get an extra 4 years or continue your degree and have the next 2 years?
Yeah, so we'll take a pause here and just talk to that real quickly. So I had a 2-year degree, which was non-calculus based, so I'd done everything like up through college algebra, that kind of things. And the physics I'd taken and chemistry I'd taken were all non-calculus based. So before this point where I went back to Portland State, I had known in that 7 years since I graduated with my 2-year degree that I eventually wanted to get a 4-year degree. So in between getting that AAS degree, I went to PCC and Clark, and I went here one class at night to do the full calculus sequence, to do the physics with calculus and the chemistry. I think those were the only things I had to kind of redo. So I had done almost 1.5 years. Well, kind of pieced out. I'd done 1 year of physics, 1 year of calculus, and 2 terms of chemistry before I could start back as a junior at the transfer engineering. Does that answer your question? Yeah, so again, while I was there, I realized I loved geology as well. So over the next couple of years, did graduate classes in geotechnical engineering and engineering geology. So kind of mix. Then I went to work for the Forest Service when I finished my bachelor's degree. Worked there in different roles as a project engineer, a district engineer, and then a forest engineer, a geotechnical engineer. Kind of worked in the regional office doing water, wastewater. So kind of a wide range of civil, and actually I did electrical for them too, just because there's not a lot of electrical people in the Forest Service because we don't do a lot of that stuff. But that was a great experience. It was a nice combination for me. I love, like I already said, I liked being outside, but this was also engineering. So if those are things that you're interested in, I highly recommend thinking about the federal land management agencies as employers. The pay is, again, not quite as good as you can make in private practice. But in general, it's kind of nice to work at a land management agency because you get to know an area really well. You get some history with an area, and you're not just moving from one project to another. So it kind of depends on what you're interested in. Some people love to do consulting work where you're a new project, new area all the time, but just keep that in mind. Forest Service, BLM, all kinds of different interesting opportunities out there. And then, so I worked at the Forest Service for about 7 years. And then my brother, I guess I haven't talked about that. My brother taught here in engineering for, I don't know, maybe 13 or 14 years. Troy, is that, you know how long Andy was here? Okay. So Yeah, so he was here teaching for a long time and I'd watched him. And I didn't think I'd like teaching because I don't like talking in front of people. I'm a typical engineer, like out, maybe that's a stereotype, but a lot of engineers are not particularly outgoing. But I was very envious of his schedule, right? Having summers off, there is pretty decent flexibility throughout the week. So Troy actually needed somebody to teach a class part-time. And so I tried that one term and I found out I really enjoyed it. Turns out I really like, this isn't the part that turns out, I really like engineering, and it turns out I don't mind talking in front of people about something that I find interesting and important in my life. So I then came here when there was a full-time opportunity, taught engineering transfer for 1 year while Andy was doing, my brother was doing something else. And then I've been teaching in the mechatronics program for about 5 years since then, until last year. My brother left Mount Hood to go on his next adventure, and now I'm teaching an engineering transfer again. So long, kind of convoluted history to get here, and I'm sorry to bore you with that to some degree, but I also do try to talk about that in this class to show that I started with a tech degree in industrial electronics. I ended up getting degrees in civil engineering. I have certificates in electrical. I have a master's cert in geology. So in engineering, there's always opportunities to learn something new. And that's one of the things I love about engineering. I can always learn a new discipline. Like right now, like Troy and I were talking this morning about somebody else who's teaching a class and wants these codes for design. And like, that's an area I've never done structural design, but it's definitely something I can get into if I'm interested in. If you get a foundational degree, either a tech degree or a professional degree, once you start working, there's lots of opportunities to kind of, as you gain experience, steer your career path to where you want to be as far as what type of thing you're doing. If you're in the office, out of the office, in the field, if you work only in Gresham or you want to travel around the country or the world, those are all options that I feel like engineering opens for you. So any questions about my background? Great question about the 2-year versus 4-year. Anything else? Okay, let's go on and see what else I have. Okay, so this is we'll get into this. I'm going to talk about a couple of cool projects about civil engineering specifically that I think are cool. And one of them is a project I worked on, one of them is not a project I worked on, but I think is a good way to talk about civil engineering. So the first one we're going to talk about is the Oroville Dam, which I can't remember when this was, like 2017, 2018. Anybody remember this happening about this? Okay, so this, you can see here, this is a dam, and what you see is actually the spillway for the dam here, where when the lake or reservoir level behind the dam gets too high and they need to let water out, they dump it down this channel. You can see this isn't a constructed dam. This is actually just rock, native rock. The built part of the dam would be off to the side here, and it's an earth-filled dam. So it's not like the dams we're kind of think of gravity arch dams or just, I'm sorry, arch dams or concrete gravity dams. This is where they just put layers of gravel and impermeable soil. And it's a tall dam. I can't remember. It's like, I want to say 500 or 600 feet, but it doesn't look, like an incredibly tall dam, like when you see those like Hoover Dam or something where it's so thin and so tall. But I'd say the majority of dams in the US are typically earth structures, not concrete structures. Anybody guess why that is? Yeah, concrete's expensive and it usually has to be brought to a site, right? So if you need a huge volume of something, if you can work with what's on site, that's definitely a cheaper way to go. So it's a really common construction method to build a dam out of earth or rock or whatnot. But the downside to that is that's an erodible material, right? If you pour water over that over time, it's slowly going to wash it away. So earthen dams will always have well, not always, usually have a concrete spillway structure. That's where they let the water go. That's not going to erode the dam they just built. Does that kind of make sense why we have this? So this one's in California. I can't remember when it was built, maybe the 60s or sometime. And it had functioned fine, but it in the months leading up to when this issue occurred, it had been a significant rainfall period. And so the reservoir was had reached its, maximum pool level that where they feel safe operating it. So they need to spill a lot of water. And it worked out. What started happening, let's see how the pictures go here. So they were spilling water and they started to notice something weird was going on. And what was happening is underneath there had been some crack in the concrete panels that made that spillway, and water was getting underneath it and eroding the material that underlied it. And you can see it's actually probably a little hard for you guys to see, but it's eroded down to bedrock. So this is in general a massive rock slope with some soil spread over it. And so they realized something was going wrong, and you can see this picture. So they shut the spillway off, but they had significant precipitation still coming. So it got to where they couldn't not spill water over it. And so they had to spill. And so this is what happened, that it just kept eating away at that weak area. And eventually it completely diverted out of the constructed channel and dug a new canyon. And so if we look back over, again, I'm sorry, it's a little hard for you guys to see out there, but this is a relatively uniform slope. You can see there's an access road, and they had already started. You can see the wall is still here at this point. The water was going under the wall and had created a small channel right down along the side of it. Whereas now we got to, it's completely bypassed that and it started ripping like a small canyon down through the side of it. And so they had to just let it go. That's better to lose that than to reach and overtop the whole thing. Oh, too far. So let me show you a couple videos of this real quick about what was going on, and then we can talk about, I guess we'll look through the pictures first. Sorry, guys. So here's a couple pictures just to show scale. This is during the rebuild, and there'll be some videos where it flies over it. Couple things to note. Can you see how tall that wall that we just looked at in the video? I mean, it looks from a distance like it's 5 feet tall. Those are people. I mean, that sidewall's 50 feet high or something. The scale of this project is just massive. So this is from across the river looking upslope again. So up there is, you can see that little piece is that tall wall that we were just looking at. A little closer as they're fixing this. And again, you can just look at how it's scoured. I mean, it's just like bare rock all the way across. And I mean, those are huge cranes, and that canyon, you can see the remnants of that canyon over there. Oh, there's a good picture we should have started with. So here is the spillway that we've been focusing on. And there you can see the constructed earth dam that they can't spill over. So you can see that's where the channel used to be. And that's where the power generation part of it is over on that side. Okay, this is kind of interesting. Let's go back. So this is the main spillway that is designed to have water on it whenever they need to let go. Over here, this is what's called the emergency spillway. And you can see it's concrete for part of it and then goes natural. And that's only supposed to get water over it in worst case scenarios when they can't dump enough water across here. And this seems like a worst case scenario probably, right? And they did spill water over that emergency one. So you can see, again, perspective is there's the main spillway, and this is where the disaster's happening. And this is a couple days after the emergency spillway did start flowing the whole way. And you can see smaller, but still significant damage to the structure on that side there. Again, there. So this is a period of time where you can see it's ripping the new canyon, but you can also see water's coming over the emergency spillway up there, just a much smaller amount and coming down through there. I think that's a good illustration of how much material was moved. Again, think of the size of that wall, or this wall up here compared to this canyon. I think we got one more showing. Oh, yeah. So that I think is a good picture too of all this material that was bedrock and the power of water running through there. It's not like this was a pile of gravel. This was solid rock that water has ripped out into a big, basically new delta at the outlet of that. So I like this as an example of civil engineering, because it talks about kind of a lot of the big areas that civil gets broken down into. So civil, we have earthwork engineering or geotechnical engineering, which that somebody originally came through they drilled holes along the alignment of that to see where bedrock was, to figure out what was between bedrock and the surface. And they decided, okay, yep, it can handle the water flow over it as far as gravity, but we need to put concrete over that to keep it from eroding, right? So that was a geotechnical aspect of the design of this. And then they gave that information, okay, the soils that are over this bedrock can handle 1,500 pounds per square foot or something. And they gave that to a structural engineer who then would design the concrete of the floor of it, and even more so the walls of it, right? That's a really structural application. How can I need to resist the force of that water on the side of the wall, keep it from tipping, and I need to keep it, yes, especially in California, the structural engineer would also be looking, what's going to happen if there's an earthquake? Is this wall going to do this? Is it going to be stable and seismic? Environmental engineers would have been involved. I don't know, during original construction, environmental engineering, we're definitely doing better about thinking about the environmental impacts of our things, but looking at the water quality pre-project, post-project, the impacts to species around there, all that sort of thing. And then there's a lot of infrastructure, right? There's a powerhouse. You can see in the background here, there's high voltage lines. So that's another thing that civil engineers deal a lot with, the siting and structure for high voltage transmission lines. There's electrical engineers that design, the capacity of the system. There's mechanical engineers that design the towers, maybe. That's one of those structures, could be. Some civil engineers might specialize in that type of structure, but that's really almost more of a mechanical frame system. So just big, all different kinds of civil engineers, and working with electrical engineers, mechanical engineers, et cetera. Then in the repair here, it's another great example of how all those different subspecialties would be involved. Again, you'd have a geotechnical engineer coming in and saying, okay, we just eroded a huge amount of material. We can't put this somewhere else. We have to build this back up in the same location. And that's a common issue in projects like this. You might wonder, why'd they just put it back right where it was? It failed there once. To a certain degree, where they don't have a lot of choices, right? The reservoir is here. And what do you think might have been one of the biggest design drivers about this project? If you can think of pressure, if you were an engineer and your boss came to you and said, okay, we have to fix this, what do you think they're going to say is going to drive your design? Money, time, aesthetics? What do you, yeah.
Probably time, because you see how below like the actual little slide, all the rock is just gone. So you're gonna have to build that up. Like it's gonna take time to put so like let's say for example, I don't know, do you guys even use rebar?
Yeah.
Like let's for example, like we just make like big sticks of rebar, putting in support panels and stuff like that.
Yeah. Yeah, so time was the driving factor here, more so than money or design or whatnot. And the reason time is these pictures here are taken during summer, right? You have another rainy season coming. Next year you're going to have to dump water over this again. And this is a huge project. Getting to where you are to fix it is going to take a lot of time. So they were already giving people contracts before they even had a design. This was a very accelerated type of construction project. And so, let's see. Okay, that's it for the images. Let's watch a couple quick videos that go over. Let's see which one. So this is in the days immediately following the kind of massive overflow. And let's speed this up. So here you can see the emergency spillway still overflowing. And you can see that it's washing away a road across here. But relatively small amount of water coming over the emergency spillway. And really, like as an engineer, I'm sure the people at California Department of Water were super strict. Like the idea is you never use that spillway. And here you're using that spillway and it's not enough. So again, this is a few days after that, or not a few days, a while after that. This is when they're starting to work on the repair. So here, this is erosion just from the emergency spillway. And you can see they're just coating the whole thing right now with concrete to form a base for what they're gonna put back on top of it. Again, just think of the scale of the amount of water that's pouring over that right now. Like that plume is 150 feet in the air. Okay. Last one. So this one is, I think, one of the most interesting. This is a compilation of drone flyovers over the project as they started rebuilding it. So I'm gonna let it run at normal speed so that I can talk a little bit while we go through it. Again, look at, sorry. Look down in this bottom corner at the scale of the dozer that's working in the bottom corner. Like these blocks of concrete are larger than like a D11 cat. Maybe we'll make it go a little faster. I don't know. Again, the size of the earth's moving equipment compared to the canyon it's carved. Okay, so now they're starting to prepare the bed for what they're going to build new. So you can see they're clearing away all the loose material up there. They're drilling. So they're probably blasting out something that's loose but not gone. And now let's pause here and talk for a minute about this. They're starting to build the new structure, and they're using a form of construction that is kind of like the earthen dam where we talked about you just pile rocks and soil, but they're using what's called roller compacted concrete. So it's not concrete that's mixed at a concrete plant like we're used to. It's made on site and it's just dumped in from big dump trucks. So it's very dry. Yeah.
So you guys just stripped off the old material and you're putting on new material.
They did. Just to be clear, I wasn't part of this project. This is just a good example of civil engineering. But yeah,
Better to, I don't know, it's like, wouldn't it be a waste of material to not use the old, like the old structure and then just fill it in with some work, like, you know? Stuff?
yeah, I hear what you're saying. But you, not really, because they can't guarantee that that stuff's going to be stable once it's been damaged. So if we look back at the start, they didn't rip everything out. Like these blocks, the energy dissipation blocks at the end, they stay through the whole thing. So there were some, it's not like they removed everything. They just removed anything that was loose or damaged. Does that make sense? So yeah, you can see they pretty much removed all of the lower section because it was just so damaged in the process. You can also see they left some of that upper section there. Let's go back to where they're starting on the roller concrete. So you can see there's kind of these temporary forms. It's basically a wall that's propped up here. They've cleaned down to bedrock, and then they're placing this concrete that's very dry. And so they don't need forms as detailed as they do for like if you pour wet flowing concrete. And they can make it much faster on site. So they just lay a layer down, drive over it with a bulldozer to push out the concrete, and then drive over it with a rolling compactor to compact it. So that's why it's called roller compacted concrete. And you can see that these are kind of baby steps still. Look at what they have to fill coming up. Again, like there's people down in the corner. So let's pause there real quick. You can see this is all that roller compacted concrete in layers of, I don't know, maybe 4 feet each. I mean, look, there's people there, and that is filled up all the way from down here to up there. And that's August, and we started May, was it the first ones here? So they're working their way up from the bottom, and here's a dozer that's pushing that dry concrete that's been dumped there by a large dump truck. I think we'll see one of those trucks in a minute. Yeah, and you can see where the dozer kind of feeding to these excavators that are tossing the dry concrete into the more irregular places that a dozer can't be driving over. And then once they get that smoothed out, they just push it around with the dozer. And you were asking about rebar. As we get further into here, I think there's some images where you start seeing the rebar cages that they have, especially on the walls. Again, just the amount of concrete. I mean, so look at that, the size from here to here, you know, that's like hundreds of feet. And that's a 6-foot lift. And they are doing that the whole way up, the amount of material involved. And looking ahead up here, you can see they're not doing roller compacted concrete. You can see more traditional form type work. And when we get up there, I think this same video shows us kind of what's going on. Okay, so here's one of what I was telling you about, a giant dump truck just full of really dry concrete. Okay, and so now they're getting to where they're tying into the old structure and new structure that's created using more traditional concrete right at this junction. So let's go back just a little bit there. See the difference between the walls down here that are like, you know, 12 feet wide. So they placed those walls using roller compacted concrete. And then where they repaired up here, they used more traditional concrete that would have a rebar structural frame inside it. Same with all the flow down coming from there. Any thoughts about why they did that on the upper section and not on the lower section? Sure.
Cool. It's gonna gain some more speed downward, right?
Yeah, so it is primarily the fact that up at the top, that's where it's going from constricted to being let out. So there's a lot of hydraulic forces that they have to account for. And the, whatever you want to call the more traditional concrete and the structural rebar in that is better for those high impact loads as opposed to the roller compacted concrete. Look at all the cranes there. I mean, it's an incredible amount of work in a relatively short time for engineering. Okay, so now we're on to a more traditional form of concrete placement. Again, look at the height of the walls with people over here. So this is all roller compacted in traditional high strength concrete. And you can see now they've poured along the walls a veneer of high strength concrete. Okay. So, yeah, question.
Is there a reason why there's a little lip?
A little lip, sorry, let me go back. Between the roller compacted section and the. Yeah, so that's a good question. I thought it showed afterwards. If I recall correctly, that lip is not there in the final product. They actually did come back with a veneer of high strength concrete. That's just. Yeah. And I thought, I'm sorry that they didn't show that, but that's why that lip was there. They then went back over, like when I talked about, see, you can see they put a veneer of high strength along the sides. They did come back and do one across the bottom as well as to handle that, the friction, and it's really erosion of the concrete. Like, I mean, that's what led to the original failure is anytime you have water flowing, there is some sediment carried in it, right? So it's kind of like sandblast or water jet cutting really. And at one of the seams before, over time, that eroded that seam to where water could get underneath the concrete. Other questions about that? Yeah.
How long was the actual spray event itself?
It was a week or two, maybe. I think it was a few days, really. It was not a significant period of time. Yeah.
Kind of, the morning of, that kind of breakage, like, whose red telephone is ringing, like, just kind of making those decisions of like, oh man, this is gonna be a long year.
Yeah. I'm trying to remember. I think this is, so that's a complicated answer because in a project this big, there's lots of people.
Yeah.
So there would be engineers on site, but when it's originally happening, it's going to be the operations people who are calling, like, they evacuated the downstream valley because they were worried that the dam would breach since everything was overtopping. So, I mean, there would be everybody involved, state and federal, law enforcement through environmental, I can't remember what the California version of that is. So even though this dam is, I believe this dam is owned by California state agency, all dams are regulated. Well, all dams at some level are regulated by the feds if they're of any significant size. Yep. Yeah, and so it's from the engineering side, the people who would have been called right away would have been the structural engineers and geotechnical engineers and hydraulic engineers. So all of those are subsets of civil to a certain degree, maybe some mechanical engineers about gates or whatnot at the top, but this really would have been, I mean, I use this one because it's really civil heavy focus about who's responding. Geologists actually would have been called right away as well, because geotechnical engineers, they focus on building with the environment, whatever's there, but they're less about what has created the environment. So there would have been geotechnical engineers and geologists looking at it from geotech engineers. How do we fix this? A geologist is what's underneath this? What can we expect about what we can't see here, kind of thing. Good questions. Other questions about this project? Yeah. Yeah, great question. What'd they do with the material in the river? I'm sure they dredged enough to get a normal channel across again and probably stockpiled it somewhere on site. But probably didn't. Well, so they could have used the roller compacted concrete, probably did use a lot of any rock that they could get and crush that was clean. They can't use rock that's got a bunch of dirt in it or whatnot. But I'm sure if they were able to isolate some of that, they would have used it to create that RCC. If they could. Yeah, so almost, from my understanding, is all the fill basically in this project was the roller compacted concrete. They didn't use any loose material to build that back up. So my guess is, I think they put a small quarry on site as part of the repair for getting rock to make the concrete. I think we only have about 10 more minutes left. The other, so we talked about my background on tech and transfer. I'll just highlight that a little more. You guys are a couple terms in here. So you hopefully got a good sense that we have an engineering technology program that's 2 years, and then you go work in industry as an engineering technician. Like everywhere I've worked, there's been engineering technicians. When that was industrial automation, that was my first job. I wired panels, I troubleshooted them. I was out in the field installing them. That's very much technician, industrial electrical technician kind of thing. In that same role, I worked for an industrial or a manufacturing engineer who designed that control system. And he would size the motors, design the gear trains, that kind of thing. So that's kind of the difference there. I had gone to school for 2 years so far. He'd gone to school for 4 years. And civil's the same way. At the Forest Service, we had tons of engineering technicians. That was actually more common than engineers because a lot of the work in the Forest Service is inspection of construction. And that's a perfect kind of common job for engineering technicians. Out on the project, verifying is what a contractor's doing, match the plan, the design plans. Then there's some engineers who are the ones who usually made those design plans. So a tech, again, might have worked with that engineer on that design, might have done some of the plan sets, the contract language kind of stuff, but that's kind of, again, that difference between, there's definitely design involved in engineering tech, but that's probably stronger in the professional engineering realm. So does that kind of make sense, the difference there? Whatever field you're in, there's probably a tech option versus a transfer option. The transfer takes 2 more years of school, and even in your first 2 years, it's just kind of a different track. It's you have to take calculus is the main one. And I'd say have to, get to, I don't know. It depends on if you love math or whatnot. You get to take physics with calculus, which I think is one of the best series of courses anybody gets to take. I love physics. So I think that's a pro. when you graduate, again, it takes 2 more years of school, so it's 2 more years of tuition, 2 more years where you're working part-time or whatnot while you're going to school. So there's definitely pros and cons. There's good jobs in both. You do have more salary potential if you have the 4-year degree. And then even once you're done with the 4-year degree, then there's a choice. Do I want to be an engineer, like just go out, be a civil engineer, electrical engineer, or do you want to be what you can call yourself a professional engineer? I mean, you actually have an engineering license, like you can stamp things and say, I guarantee this is good, that this meets codes, that this isn't going to hurt somebody. And that's another option for you. It takes another 4 years after your bachelor's degree, just of work. You need, so basically to be able to take the test to become a professional engineer, you have to have 8 years of engineering experience. 4 years of that can be education. So your 4-year bachelor degree counts, but then you have to work for 4 years as an engineer under the oversight of somebody who's a licensed engineer. So just keep that in mind. That's a decision point you might make if you're going into the 4-year engineering world. So for example, I worked as a civil engineer for quite a while, and then I went back and took the test and whatnot to get my PE in civil engineering. And civil is one of the more common fields, probably. Electrical is another good one. I feel like mechanical, it's maybe a little less common to get your PE because there's less jobs where that's kind of like a requirement or whatnot. Yeah.
We're going back to get a master's.
I think it does. I think you can only get credit for 4 years of education. Is that right? Yeah. So it's definitely a benefit to you to go back, but I don't think it helps against those years. And what I'm describing is the typical track for PE licensure. There are, I think, are there still? They've gotten rid of the exceptions. Okay. They're definitely moving to where you have to get that bachelor's. It used to be if you had worked 8 years under a licensed engineer, even if you didn't have that traditional education, you could take the test, but it's definitely getting harder to do it non-traditional track. Yeah.
So about that, part when you said, I don't remember which role it is you said, but you gotta stamp it and approve it, right? Don't you have to have OSHA do it before you or after?
No, that's kind of why you're licensed. You're saying that your design meets all the requirements, like from the building code, from the structural code, from the fire code kind of thing. So if some OSHA reviews workplace safety is basically OSHA's realm. So OSHA would come into it when your design that you've stamped is being built. If the contractor is not following OSHA protocols, then they're going to get in trouble. The engineers, unless you're designing a construction sequence, a plan, and you say, go do it this way, it's relatively unusual. Engineers write things to OSHA standards, typically more often building codes, structural codes, electrical codes, that kind of thing. Other questions about engineering, civil engineering? If not, oh, yep, go ahead.
Is it fairly common for those things like to work somewhere where they facilitate me going and getting my bachelor's?
Yeah, it really depends on where you are. I'd say it's definitely that's a common thing, but it's not a guaranteed thing by any means. And those workplaces that do say they support education, I think they usually do, but it's usually on typically a pretty part-time, like you can take one class a term in the evenings kind of thing. If you've got a great employer, they might say you can take classes during the day. That's been my experience. I'm afraid it probably varies a lot from place to place. So I guess the last thing, I've got like 2 minutes, I think, that I think college success, is that something, a quick blurb on? Whether you're tech or transfer, things that I think are important for you to be developing the habits in school that'll lead to your success in employment, or being honest about when you don't understand something. Troy and I really like teaching. I enjoy people learning something, but And I try to provide all the information you need to learn in my lectures or whatnot. But sometimes not explain something clearly. It's hard for me to know that if you don't come talk to me. And in your employment, it's hard to go tell your boss, I don't know how to do this, right? It's better to tell them that as soon as you get an assignment, instead of 2 weeks later when they say, how are you doing on this? And you're like, yeah, I don't know what to do here. So in school and in your career, be humble about what you know and what you don't know. People recognize we're all learning things, and people who know something usually like to teach somebody else about it. So that's one thing. Talk to people when you need help, be able to say, I don't know, and just develop good work habits. I don't know, COVID, I don't know what the deal is. Over the last couple of years, I get so many more emails the night before an assignment is due now. And I've tried to be flexible. Like, I'm trying to make my assignments available a week ahead of time. So like, you got a week. Don't wait until the day before something's due to start working on it. I recognize we all have lots of competing life pressures, work, family, whatnot. I'm not saying you have to get it done the day it's assigned, but at least open your assignments, take a look at the assigned reading, get a sense, oh, I'm going to have trouble on this. I should not wait till Sunday afternoon to start this kind of thing. Be a little proactive in your work. Will go a long ways, because I'm more available during the week. I don't know about Troy, and that just gives us, you and me, more time to help figure out something you're not understanding and before it's due, kind of. So last college success thing is develop some buddies in your group. I'm not saying you're going to be best friends, but at least have some email addresses or whatnot that if you miss class, you can say, hey, what did Troy talk about? What did you guys read? What problem should I do to review? Don't live in isolation as you're trying to get through school. It's hard to do things on your own. Not saying somebody else is going to do your work for you, but being able to ask a question, hey, I'm completely stumped on this problem. How did you start this? That kind of thing. And I've gone too long as always. So it's nice to see all your faces. If you're a transfer major, I'll look forward to getting to know you more. Hopefully, as a heads up, I'm probably on sabbatical next year, so you might not see me next year, but maybe we'll see. You never know. So I wish you all well. My office is right across the hall from Troy's. If you ever have questions for me, advising about transfer engineering or whatnot, feel free to come see me. Yeah. Yeah. My on-campus office hours this term are Tuesday mornings, kind of during this time right here, unfortunately. But then I do Zoom office hours anytime.